All right. I'm back. Sorry about that. Sometimes when you get a call from your folks, you don't say no. So, hopefully, I don't think it's the same link, but that's okay. We'll just continue. So, when you name an aldehyde, so for example, if you were given this, you know it's an aldehyde because of this group at the end, that C double bond O attached to an H. So, count your carbons. There's 5. That's normally pentane. But since there's an aldehyde group attached to it, we call it pentanal. Pentanal. So what I'm thinking is I'll wrap up table R, and then tomorrow we'll do the reactions, because this video is already going to go pretty long. A ketone. A ketone has a double bond O attached to a carbon somewhere in the middle of a much longer carbon compound. So, you need the number because you need to indicate where is that double bond O. And instead of the ending being pentane, it's now pentanone because it's a ketone. So, what does it look like condensed? So condensed, 2, nope, not 3, 2, I said 2, C, O, CH2, CH2, CH3. So, that carbon right here, that's just missing a hydrogen attached to it, but has that O next to it, must be double bonded to the O and then attached to the 2 C's at the side so that that carbon has 4 bonds. Because remember, carbon always wants 4. So when you draw this out, CH3 takes care of that. CH2 takes care of that. CO, C takes care of these. H2 takes care of that. CH2, gone. And then CH3. So whenever you see a carbon compound, and one of the carbons in the middle is just missing a hydrogen, because you know these organic compounds have hydrogens all over the place, but please keep in mind, organic means carbon. That carbon must be double bonded to that O, so that carbon can get to 4 bonds. Well, how do you name this? We have our sandwich C double bond O next to 2 carbons. Count your carbons. There's 6. That's normally hexane, but since there's a double bond O, it's hexanone for ketone. Okay. Next, organic acid. We'll have this group somewhere at the beginning or the end of the compound, never in the middle. It's one of 2 groups that have 2 oxygens. So there's 2 O's in this compound. All the other ones above it only have 1 oxygen. 1 oxygen. 1 oxygen. 1 oxygen. 1 oxygen. 2. But the only other thing attached to the oxygen is an H. So when you name it, instead of it being propane, it's propan, change the ending to oic, acid. Propanoic acid, butanoic acid, pentanoic acid, hexanoic acid. So, let's do a practice one. What does it look like condensed? So CH3, CH2, CH2, COOH. That's what it would look like condensed. It ends in coo or co-o. So let's draw it out. people who like don't have me as a teacher must think I'm crazy. My students probably think I'm crazy. I am crazy. That's okay. CH3. C, H2. C, H2. Whoop, why did I draw a dot up there? C double bond O, OH. How many carbons? 1, 2, 3, 4. Normally you would say this is butane. Make that look like butane. Because 4 carbons is but, no pun intended with the but, it's not butane anymore, it's butanoic acid. Just to reiterate here, I might have these prefixes memorized. You don't have to. Again, they're on the reference table, these organic prefixes. So don't memorize them. Always double check your prefixes on table P for prefix. Nope, I wanted to stay there. Next, ester. Ester is very similar looking to an organic acid, but the difference is this carbon compound has a C double bond O and then an O somewhere in the middle. So this is like somewhere in the middle of the compound. Not at the end, not at the beginning. This is in the middle of the compound. And these are by far the most complicated to name. So let's look at the example. What you have to do is look at the group that comes after the O, and you name that group first. Then look at the 3 carbons that come before the O, you name that group second, and instead of the ending being propane, it's propanoate. So, what does this look like condensed? So the easiest way I've remembered it is that to know you have an ester, it's going to say the word cook in it. Oops, I didn't want to draw that line there. So, a lot of older grandparents, there's some young people named Esther, but I think Esther is kind of not as popular as it used to be. So, like, my grandma Esther was a cook. Ah, see, this says the word says the word cook in there. So, let's draw it out. CH3, C, H2, C, O, O, C, H2, CH3. This group right here, that sandwich COO, is an ester. Highlight this. Name that first, ethyl. Highlight this. Name that second, sorry, I missed one. That's not F. Did I draw that right? Yeah. 3 carbons is prop. And it's not propane, it's propanoate. So, ethyl propanoate. Ethyl propanoate. The last 2 are the only ones with nitrogen. So, amines have nitrogen and amides have nitrogen. If it's just a nitrogen, it's an amine. If there's a nitrogen with an oxygen, it's an amide. And the ending is really easy. Write the word amine. Write the word amide. So, condensed, it's pretty straightforward. If condensed, it has an N and not an O, it's an amine. And if it has, this one condensed would be like CH3, CH2CON. If you see the ON, you have an amide. So as soon, ignore the entire top half of the table and just go straight to the bottom where the nitrogens are. So, let's name a couple. Let's do CH3, let me draw it. So when you do an amine, you need a number. You need to tell me where that nitrogen is, because that nitrogen can move around. So you can do like C, NH2, and then draw in the rest of your bonds with H's. So this, name your longest chain, pentane, but it's not pentane anymore, it's pentanamine. Where is that amine? On carbon number 3, pentanamine. But if it's an amide, no number. You don't need a number if it's an amide, because that NO combo is going to be at the end of the compound. So no worries. You don't need it. Hooray. 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 No number needed. So, let's name an amide. I'm going to do the same kind of deal as above. 3, 4, 5. And keep in mind, with an amide now, you're going to get that oxygen in there. So you need that oxygen in there. So you get your double bond O with your N. 5 carbons. Pentane. But it's not pentane anymore. It's pentanamide. There you go. I think that's a good place to call it right now. We're going to wrap up organic tomorrow, do redox tomorrow. Thursday is nuclear. That's it. So, that's all I got. Have a great, fantastic, wonderful evening.